our quadratic functions, instead of me saying, okay, use this and this and this for x, we're going to have a method to go about it. So we're going to start with learning that we haven't learned this yet. Here's something else we can add into our array of quadratic function skills. The y-intercept of a quadratic function will always be the c value of the function. So we've already used the a and the b to help us find the axis of symmetry, which also helps us find the x value of the vertex, but we've left out the c. The reason is because the c actually tells us what's the y-intercept when the equation is in standard form. In other words, don't try and determine what c is if it's not in standard form first, or you're going to get the wrong y-intercept. Okay? So we're going to, after we are sure that the equation is in standard form, we're going to look at that c value and say that's the y value where it will cross the y-axis. And then, so that's something new that we're learning. To graph a quadratic function, here are the things that we're going to actually use to get the points that we need. Because I'm going to say you have to have at least 5 points. So if you're going to fill in that blank, we're going to use the axis of symmetry. So we're going to find that. Just like we have been doing, we know how to do that. Well, the axis of symmetry helps lead us to the vertex, so we'll find the vertex. We'll use that y-intercept that we now know we can get by just looking at the c value. And not the x-intercepts, but symmetry. You don't know how to find the x-intercepts. Well, you do know how to find the x-intercepts one way, but which are also known as the zeros. But I'm yet to teach you how to find the zeros the other way, which is actually an easier way. So let's work with symmetry along with this other stuff to help us get at least 5 points. How many? What's the base number for a linear function? 3, guys. 3 was the minimum for linear I wanted from you. For quadratic, I want a minimum of 5. Does that mean you can't do more than 5? No, that isn't what that means. It says the minimum number. Okay. Let's look at our first one here. Is our equation, first of all, in standard form?
Yes.
Ready to identify the a, b, and c. Okay, what's our A? What's our B?
6.
And our C? 9. Okay, we're going to use all of those today. So what's our y-intercept? 9. Remember, the c value is your y-intercept. So that would be what point on the graph? 0, 9, yeah. So there's one of our points right there. There's our first point. Not necessarily the first one that we'll graph, but it's the first point that we're going to find. It's an easy one to find. Didn't have to work very hard, did we? Okay, axis of symmetry is what we're going to do next, because then the axis of symmetry also leads us to the
Vertex.
x value of the vertex, doesn't it? Okay, so let's do our x equals the opposite of b over 2a. So we're going to put in our b value is -6, our a value is 1. 2 times 1 is 2. -6 divided by 2 is -3. The opposite of -3 is +3. Okay, so we now know the axis of symmetry, which we're actually going to draw today on our graphs. Okay, but then that also tells us, you know what? In the vertex, we have a 3 for x, and now we have to find the y. And that's what we did in our homework for today. So we're going to substitute into our equation. I'm going to change it to add the opposite so that I maybe will be a little more successful. Y equals, what's going in for x? 3. So go ahead and get your y value. Anybody else get 0 for what? So we just found one of the what? Zeros. Are there any more zeros? Think about this. What are we looking for right now? What are we finding? finding? We weren't really looking for the 0, but we found it. So what were we really looking for?
Vertex.
Vertex. If the vertex is a 0, can anything else be a 0?
Nope.
No, that means the vertex is sitting on the x-axis. Is it opening up or is it opening down?
Opening
It's opening up because it has a positive A value. So here's that we already should have a little bit of a picture. We can say, oh, our vertex is ordered pair 3, 0. That means I've got the vertex sitting on the x-axis, and it's going to be opening up because there's an A value. So let's go ahead and graph our vertex. And then what I want you to do is with this ruler that I'm going to pass out to you, I want you to make a dashed vertical line going through that vertex, because we know that that's where the axis of symmetry goes anyways, through the vertex. So I want you to draw a dashed vertical line going through that point before you graph any other points. So we have a dashed vertical line going through, well, I gotta redo mine. Right there. And you dash it because you want to show that it's really just an imaginary line. But the reason we're going to put the axis of symmetry on there is because we're going to use it to mirror other points. Okay, so now we have another point up here. We know where the y-intercept is. It's at 0, 9. So we're going to go put that point on the graph. So we'll put 0, 9 on there. So with 0, 9, we just grabbed our y-intercept. Does that one have a point symmetric to it? Does that one have a mirror point?
Yes.
Yeah, it does. And it'll have the same y value, so it's got to have a y value of 9, but it's going to have a different x value. In fact, it's how many units away from the axis of symmetry?
6.
No, how many?
3.
It's 3 units away from the axis of symmetry, so we go to the axis of symmetry and go 3 units on the other side and graph ourselves a point. So they are 6 units apart now, but yeah, one's 3 units from the axis of symmetry, so is the other one. They're symmetric. Okay, they have the same y value. So we have 3 of our 5 points now, right? Okay, but we don't get to be done. Because now it's kind of like, now this is when Daylon asked, do we get to pick our own x values today, or do we have to, or something like that? I said, well, yeah, you are sometimes going to have to. One time, like right here. It says, pick an x value between the, well, since our y-intercept was up so high, do you think it would be a good idea to pick a point that's to the left, an x value that's to the left of 0 for x, or in other words, to the left of the y-intercept? Or would it make sense to pick an x value that's over here to the right of this point? Why not?
Then you're putting them.
Well, no. When we plug them in, if I picked x equals, let's say I picked x equals 5, and I put it into the equation, since it's going to open up, where will that point be? Way up there somewhere, up our graph. Will we be able to graph it? No. It's there, but we don't want to extend our graph. So what we're going to do instead is we're going to say, well, since those guys are so far apart, let's pick an x value that's between the vertex and either that point's x value or that point's x value. So in this case, we're going to pick an x value between the vertex and the y-intercept. Let's decide what x value could we use that's somewhere between the vertex where the x value is 3 and the y-intercept where the x value is 0. So let's pick an x value somewhere in between there. 2, okay. X equals 2. How about x equals 1? Do you want that quite as hard?
Yeah.
How about x equals 1? So how do we get?
We put it into the
Put it into our
equation.
yeah. So we're going to go substitute into our equation that we had. So y equals, we have 1 squared plus negative 6 times 1 plus 9. I happen to get y equals 4. So what order pair did you just find?
1, 4.
1, 4, yeah, ordered pair, 1, 4. There's our fourth point for our graph. So we're going to go to x equals 1, y equals 4, and we're going to plot a point. So it's a pretty good location, it's going to be on our parabola, huh? And then we're going to use symmetry to get our fifth point. So this one's 2 units away from the axis of symmetry, so I go 2 units to the other side, and I have my fifth point. And we have a minimum of 5 points. So we really only had to work to find 2 of them, didn't we? We had to do the work to find the vertex, and we had to do the work to find that one point in this case. We
You
didn't,
cannot always pick one.
pardon?
You always pick one.
No, you can't always pick one.
Is it because
It
of
depends on where the vertex is and where the y-intercept is. That's what's going to help make that decision. Okay, and then we know that we have a parabola here, so we will draw its U-shaped curve, not a V, and we'll send it through the graph, which in this case it has to anyway because the y-intercept is up so high. And we grabbed it without making a table. Okay, questions on that one at all? Anything that didn't make sense? Still. Okay, let's do one more together. Because sometimes we don't get integer numbers to work with our vertex like we learned yesterday, right? Okay, so we're going to graph y equals negative 2x squared plus 6x plus 2. First of all, is it in standard form?
Yes.
Okay, is it going to open up or is it going to open down? Down. So we better hope that when we're done graphing this, we have a parabola opening down, right? That should be something that when you're graphing it and that's not happening, you're like, oh, wait a minute, something's wrong here. Okay? So our A value is negative 2, our B value 6, our C value 2. So then what's the y-intercept? 2. Remember the C value is our y-intercept. So that's really ordered pair what?
0, 2?
0, 2. There's one of our points for our graph. Well, we don't start with that one typically. We start typically with vertex, and then draw the axis of symmetry, and then go from there, okay? Because sometimes, do you think the y-intercept could actually turn out to be the vertex? In other words, does the vertex ever sit on the y-axis?
Yes.
Yeah, sometimes it does. So axis of symmetry. Let's go ahead and get that figured out. We already have been getting enough practice in this. We should be good at it. Two times negative 2. Negative 4. 6 over negative 4. 6 over negative 4.
2.5.
Negative 1.5.
Right, negative.
And the opposite of negative 1.5? Positive 1.5. So this is x equals 1.5. And since it's a nice decimal, we could also treat it as 1.5, right? Your call, whichever one you want. This one, if you're going to keep it as a fraction, it might even be better to work with it as 3/2. I typically leave them as fractions. So what are we going to do with that 1.5 or that 3/2 or that 1.5? Put it into our equation to get our y value of our vertex. So we have negative 2x squared plus 6x plus 2. I'm going to do it with the fraction, you do it with the one you want to do it with. I'm going to show you that we can work with fractions. It's okay. They're not so bad. I use rehab. Because I like it.
How do you like that? Fairly easy.
Not bad. It's that you can do it. So you should get 6.5 or 6.5 for your y value. So we now know the vertex is at 1.5, 6.5. This is our vertex. Okay, that's the first point we're going to graph actually. So we go to the graph and graph 1.5, 6.5. Should be in the middle of a square on your grid. 1.5, 6.5. We're going to let the grid lines always be 1 unless I tell you otherwise. It's right in the middle. Okay, take your ruler that I gave you and draw the axis of symmetry, dashed. This is interesting for me to do because it never wants to go through the middle and it should, but we can go today. So it should be crossing the x-axis at 1.5, your vertical line, going through your vertex. What would be the next thing we would graph?
Y-intercept.
That y-intercept that we have. What is our y-intercept? 0, 2. So we'll go and graph 0, 2. So the point that's on my dashed line is my vertex, 1.5, 6.5. Now I put 0, 2, I put a point at 2 on the y-axis. And there's going to be one symmetric to that one because it's not the vertex. So how far away is it from the axis of symmetry?
1.5.
1.5 units. So we go to the axis of symmetry and go 1.5 to the other side of it and we put a point. Okay.
Two more minutes.
Now, those points are fairly close together. I mean, when I talk up and down. So this time we're probably not going to want it. It says the x value between the y-intercept and the vertex. Well, we could pick, like, that would be x equals 1 or x equals 2. But let me caution you about something. If we pick x equals 1 or x equals 2, it's going to have to be somewhere in here, isn't it? It's going to have to be somewhere in that region. Because, you know, it's got to be in between here. So that's a pretty small picture of our parabola. So let's pick one outside of it. In other words, I would instead pick 1 to the left of the y-intercept. Let's go outside of it. Let's get one that's maybe down further. So -1. So x equals -1 we could use. So y equals, or -2x squared, plus 6x, plus our 2. So -2 times -1 squared, 6 times -1. When you're done, you can see if you need to change my mind or if I need to change yours. How do you feel about my y equals -6? Anybody want to thumbs up me? Oh, that's a big goal. So then this is ordered pair what? -1, -6. So I go to my graph and I put a point at -1, -6, and good news, it's still going down, right? And then I reflect. Well, how far is that from the axis of symmetry? How many units? 2.5. So I'm going to go 2.5 the other way and make my 5th point. And I'm feeling pretty good about my parabola because it's opening down. And I'm such an artist, I can draw a U-shaped graph
That's just like we did.
and all is well. Okay, questions about it? So this is, you have